Welcome back to Trust Me, Bro. GTC 2026 was not a product launch. It was a declaration of intent. Jensen Huang just showed the world that NVIDIA is no longer a chip company. It is building the operating system for everything. But before we dig in, 40% of you aren't subscribed yet. Come on, hit that follow button and collect our episodes at pods.media. So, for our mission today, we're unpacking something just, well, massive for you.
Yeah, massive is an understatement, honestly.
Right. I mean, we are diving into Jensen Huang's staggering 10,000-word keynote from GTC 2026. And, alongside that, a whole stack of industry reports that dropped right around the same time.
Yeah.
And sifting through all this source material, it genuinely feels like we just watched the tech industry's tectonic plates shift in real time.
It really does. Because if we look at just the sheer scale of the roadmap they laid out, this was fundamentally about redefining civilizational scale computing. I mean, the core framework NVIDIA introduced is what they're calling the AI layer cake.
The AI layer cake. I love that branding.
Right, it's catchy. But they've basically broken down the entire future of infrastructure into 5 distinct layers. So you have energy, chip technology, infrastructure, AI models, and applications.
Okay, so 5 layers.
Yeah. And for the last 2 decades, the market viewed NVIDIA as sitting purely in layer 2, right? Just printing the GPUs. But what this keynote reveals is that they are no longer waiting for the rest of the world to build the supporting ecosystem.
Oh, they're taking over the whole stack.
Exactly. They are actively defining the physical and software infrastructure for every single layer of this new industrial revolution.
Okay, so let's unpack this layer by layer because I feel like we really can't grasp the software or the AI models without understanding the massive paradigm shift happening in the hardware first.
Hardware is the foundation.
And the boldest claim across all these reports is that the traditional data center, like the way you and I have thought of it for the last 20 years, is officially a relic of the past.
Yeah, it requires a complete reframing of purpose. Jensen Huang introduced this concept that just completely changes how we view real estate and power. He said future facilities will not be designed to store data.
Which is wild to think about.
Right. Instead, they'll be gigawatt-scale AI factories, and their manufactured product, like the actual widget coming off the assembly line, is the token.
Wow. Okay, so if the traditional data center was like a giant library storing books for you to retrieve, this new AI factory is a power plant, and the electricity it generates is tokens.
That is a great way to put it. The entire facility, from the cooling to the networking, is optimized purely to produce tokens of intelligence.
The entire economic baseline of tech was just reset.
Yeah.
And the engine of that new factory is the Vera Rubin platform, right?
Yes, the Vera Rubin platform. And the specs highlighted in the reports are just mind-blowing.
I mean, they're claiming a 5x leap in inference performance compared to the previous Blackwell generation, and a 10x reduction in inference token costs, 10 times cheaper.
Which is a huge deal for developers. But, there's a specific detail that really stood out to me.
Oh, the Grok integration.
Exactly. They are merging Grok's LPU, the language processing unit, directly into the Vera Rubin system, and they're promising a 35x performance improvement for ultra-low latency inference.
Okay, wait, I need to zero in on this. How does merging 2 completely different chips actually yield a 35x jump? That sounds like marketing magic.
I know, it sounds crazy. But it comes down to fundamentally different architectures solving different bottlenecks. So traditional GPUs are incredibly powerful, but they operate a bit like a bustling city with traffic lights.
Okay.
Data moves around, stops, waits in queues in the memory, and then moves again. It's efficient, but there's latency. Grok, on the other hand, uses a deterministic data flow architecture with massive amounts of on-chip RAM memory.
Deterministic meaning?
Meaning, instead of data waiting in traffic jams, the routing is mathematically predicted and scheduled in advance.
Oh, I get it. So, if the GPU is a city with traffic lights, the Grok LPU is like a perfectly timed high-speed rail network where the trains literally never even have to brake.
That captures the mechanics perfectly. So when you combine Grok's deterministic scheduling with Vera Rubin's raw computing power, you get systems capable of processing trillion parameter models with almost zero delay.
The data just never stops moving.
Exactly. But solving the silicon bottleneck immediately exposes the next much harder bottleneck, which is power.
Right, because you can't just infinitely scale up a power plant.
No, you can't. A 1 gigawatt facility is physically capped at 1 gigawatt.
Right.
So the metric the entire industry is pivoting to isn't just speed anymore, it's tokens per watt.
Tokens to what? Right, because if you're building a factory, the cost of the electricity to run the machines eventually outpaces the cost of the machines themselves. So how are they addressing that power ceiling?
Well, they introduced a new software layer called DSX Flex, and it's designed to unlock up to 100 gigawatts of what they call stranded grid power.
Stranded power, what does that mean?
It's basically unused energy. The software allows these massive AI factories to act as grid-flexible assets. Let's say a massive wind farm is generating excess renewable energy at 2 in the morning, but the local city doesn't need it.
Okay, everybody's asleep.
Right. DSX Flex detects that excess, instantly spools up the compute to run heavy AI training workloads, and then scales it back down when the grid is strained during peak daytime hours.
Oh, wow. So they just soak up the cheap, unused power dynamically.
Exactly, and we're already seeing this deployed. Eli Lilly just launched the first pharma-owned AI factory, which is designed to accelerate drug discovery using this exact flexible infrastructure.
Okay, so if we have unlocked all this stranded power to generate literally billions of tokens, my immediate question is, what are all these tokens actually doing?
That's the billion-dollar question.
Because, like, simply generating text for chatbots isn't going to consume the power output of a small country.
No, definitely not. And to understand the scale of the power draw, you have to look at a staggering statistic from the keynote. Overall, computing demand has increased 1 million times in just 2 years.
1 million times.
Yeah. And specifically, the inference stage, the moment where the AI is actually answering your prompt and doing the work, that now requires 100,000 times more compute than the initial training phase. Jensen's phrasing was, AI needs to think now.
Wait, hold on. Let me push back on that. 100,000 times more compute for inference.
Yeah, it's a massive flip.
But training a frontier model takes months of supercomputer time and thousands of GPUs. How can just asking it a question, the inference, take more power than building the brain in the first place?
Because the nature of the prompt has changed. We aren't just asking it to write a poem anymore.
Yeah.
We're asking it to execute complex multi-step workflows.
Oh, I see.
Yeah. When you give an advanced AI a task now, it doesn't just generate a single stream of text. It creates a plan. It runs a simulation of that plan. It checks its own code for errors.
Right, it self-corrects.
Exactly. It realizes it made a mistake, rewrites the code, spawns 3 subtasks to gather more data, and then synthesizes the result.
Jeez.
That iterative loop, the thinking part, requires thousands of hidden inference calls for every single output you actually see. It's no longer just pattern recognition, right? It is autonomous reasoning.
And the poster child for this new era of action is OpenClaw. According to the sources, this open-source personal AI agent surpassed 30 years of Linux growth in just a few weeks.
It's unprecedented.
It's basically an operating system for intelligent computers. It doesn't just give you answers, it literally moves your mouse and clicks your buttons.
Yeah, and NVIDIA's enterprise answer to that viral growth is NVIDIA.
Yeah.
This is a really crucial move where NVIDIA is extending its moat from hardware deep into the software layer.
Like locking people in.
Exactly. NVIDIA allows a company to build always-on AI agents that autonomously execute those massive multi-step tasks we just talked about. And they can spawn their own sub-agents to handle specific chores.
Okay, but what about data privacy? Because corporations hate sending their internal data to the cloud.
That's the genius of it. Crucially, for corporate security, they run entirely locally on NVIDIA hardware without needing to constantly ping a cloud server and expose proprietary data.
Okay, let me digest the implications of this for the listener. Are we looking at the death of traditional software? Like instead of you opening an app, clicking a menu, and filtering a spreadsheet, you're just going to have an army of mini AI workers running around your local machine, executing tasks in the background.
Jensen Huang made that exact prediction. He stated point blank that 80% of current applications will just disappear.
80%.
Yeah. The entire SaaS industry software as a service will have to pivot to become agent as a service. In the near future, you won't buy a CRM tool you have to log into and manage yourself.
You'll just hire a digital agent.
Precisely. You will hire a digital agent that manages the CRM for you. The operating system on your computer transitions from being a filing cabinet to being a manager of digital workers.
Man, that fundamentally changes what it means to use a computer. But if NVIDIA is the digital mind, the manager assigning tasks in the background, what happens when that mind needs a physical body?
That is where things get really sci-fi.
Because the keynote heavily featured the era of physical AI. And I have to admit, the most visually striking part of the presentation was that Disney and DeepMind Olaf snowman robot walking out on stage.
Oh, yeah, it was a great visual. But, the tech running it is what actually matters.
Right.
The robot was powered by the Newton physics solver and the Cosmos world model. It wasn't remote controlled. It was making real-time physical decisions to balance, walk, and interact with its environment.
And the strategy behind that cute snowman is what really fascinated me in the reports. Because for years, the biggest bottleneck in robotics hasn't been the metal or the motors, right? It's been the training data.
Oh, absolutely. The physical real world is just too messy.
Yeah. It is incredibly expensive and slow to have a real $1 million robot stumble around a physical lab trying to learn how to pick up a coffee cup. But NVIDIA is attempting to turn robotics' biggest physical bottleneck into a pure compute problem. How exactly are they doing that?
By entirely removing the physical world from the training phase.
Wait, entirely?
Entirely. They're using synthetic world generation, specifically their Cosmos 3 model, combined with a reference architecture called the Physical AI Data Factory Blueprint.
Okay, so a virtual world.
Exactly. They build these highly realistic, physics-accurate 3D simulations. The simulation calculates exact gravity, friction, lighting, material density, everything. And the robots undergo millions of hours of trial and error in these virtual environments.
So they're learning without breaking real hardware.
Exactly. The software learns how to walk, grasp, and recover from falls in the simulation before the code is ever downloaded into a physical metal chassis.
So instead of a robot painstakingly learning to walk by falling over 1,000 times in a real-world lab, it's like the Matrix.
Yeah.
We're just downloading kung fu into its brain via synthetic simulation before it ever throws a real punch.
I love that comparison. And the results they published validate that approach. NVIDIA unveiled the GR0DN2 Humanoid Foundation model, which was trained in these massive synthetic environments.
And how does it perform in reality?
Incredibly well. Because they can simulate endless edge cases, like a floor suddenly becoming slippery or a target object being obscured by shadows, the GR0TN2 can successfully complete entirely new tasks in unfamiliar real-world environments more than twice as often as previous leading models.
Wow.
They essentially solve the chaos of the real world by simulating the chaos.
And they're installing this physical AI brain into absolutely everything that moves. Like the sources highlight that autonomous vehicles are officially crossing from endless R&D into reality.
Yeah, it's finally happening.
Uber, partnering with Nissan and Wave, is launching Robotaxis in Los Angeles by 2027, all utilizing the NVIDIA Drive Hyperion platform. But putting a supercomputer in a car is one thing. How does the network keep up with thousands of cars making autonomous decisions in a crowded city?
Well, this brings us to the edge infrastructure layer of the cake. Telecom giants like T-Mobile and Nokia are actively turning their 5G networks into distributed edge AI infrastructure.
Okay, explain that.
So, if an autonomous vehicle or an industrial drone encounters a complex situation, sending heavy, uncompressed video data all the way back to a centralized cloud data center hundreds of miles away, that introduces latency.
And in a moving vehicle, latency is dangerous.
Exactly. You can't afford a half-second delay at 60 miles an hour. So by upgrading the 5G cell towers with AI compute, the heavy processing happens at the nearest tower.
Oh, so the tower itself does the math.
Yes, the tower effectively becomes an instant extension of the vehicle's brain.
So the cell towers themselves are doing the thinking, keeping the latency down to single-digit milliseconds. But NVIDIA isn't stopping at cell towers in Los Angeles. The reports detail that they are going to the ultimate edge, which is space.
This was the wildest announcement.
Right. They announced the new Vera Rubin space module, which delivers up to 25 times the AI compute of an H100 chip, specifically designed and hardened for orbital data centers. Companies like Kepler and StarCloud are already deploying this. I just have to ask, why on Earth or off Earth would we go through the massive expense of putting a data center in orbit?
It sounds absurd, but the logistics actually solve several terrestrial bottlenecks. First, in specific orbits, you have access to continuous, uninterrupted solar power. No grid limits.
Oh, okay. Infinite sun.
Right. Second, the thermal dynamics of the vacuum of space provide a simplified cooling environment, which is critical given the immense heat these dense GPU clusters generate.
Space is cold. Got it.
But the primary driver is solving the bandwidth bottleneck for geospatial intelligence.
Meaning satellites looking back at the Earth.
Exactly. Earth observation satellites are generating petabytes of high-resolution video and radar data daily. If you have to beam all that raw imagery back down to an exhausted terrestrial network just to be processed, you clog the radio frequencies and waste so much time.
So process it up there.
Exactly.
Yeah.
By putting the data center in orbit, the AI analyzes the raw imagery in space. It identifies the supply chain disruption or the weather pattern or the military movement, and it only beams down the finished lightweight insight.
Oh, that makes perfect sense. A simple text alert is infinitely cheaper and faster to transmit than a 4K video stream.
Exactly.
Okay, so we have gone from gigawatt AI factories on Earth to data centers floating in orbit. Let's bring this right back down to the device sitting on the listener's desk. Because NVIDIA isn't just dominating the cloud and the cosmos, right? They're coming straight for the PC market.
They are, and this introduces a major structural shift for both the consumer and enterprise hardware industry. NVIDIA announced the N1X AI PC chip.
The N1X.
Yeah, this is an ARM-based system-on-chip, meaning the CPU, the memory, and the graphics are all unified on one piece of silicon built in partnership with MediaTek. And it features an integrated GPU that performs at the level of a standalone RTX 5070.
That's a lot of power for a single chip.
It is. And the entire strategic purpose of this chip is to run those NemoClaw AI agents we discussed earlier entirely locally on your laptop.
Which solves the privacy issue, because if you're a lawyer or a healthcare provider, you can't have your AI agent sending sensitive client data up to a public cloud to be processed. You need the agent thinking on your physical device.
Precisely. It secures the data and reduces cloud compute costs for the enterprise. Win-win. But, hardware is useless without developers building for it.
True.
To bridge that gap, NVIDIA rolled out the CUDA 13.1 update, featuring something called CDA Tile.
CDA Tile.
Yeah. See, the complexity of modern chips with their extremely specific tensor cores and memory hierarchies, it has become a nightmare for software engineers. CUDA Tile basically abstracts away all that specialized hardware.
Okay, so how does that help the developer?
A developer can focus purely on writing the logic of their algorithm, and the compiler automatically figures out the most efficient way to map it onto the physical silicon.
Wow, so it's essentially an auto-translator for the hardware.
Exactly. It removes the friction.
But zooming out from the specific chips and software for a second, I want to look at the sheer dominance of NVIDIA's multi-year roadmap. Because they didn't just announce Vera Rubin for today, they gave the industry complete visibility into Vera Ultra in 2027 and the Feynman architecture in 2028.
Yeah, laying out a timeline like that is a huge flex.
And the specs for Feynman are wild. It's slated to use a 1.6 nanometer process and something called silicon photonics, which unlocks a 10x bandwidth improvement. What exactly is silicon photonics?
So currently, chips communicate by pushing electrons through copper wires.
Right.
As you push more data faster, copper creates electrical resistance, which generates massive amounts of heat and physically slows down the transfer. Silicon photonics replaces the electrons with light.
Light, like fiber optics.
Exactly. It integrates tiny lasers directly onto the silicon, transmitting data via photons instead of electricity.
So instead of pushing electricity through copper wire and fighting the heat, they're literally shooting lasers through the chip. They're turning the motherboard into a microscopic fiber optic network.
That is exactly the mechanism. It drastically reduces power consumption while allowing components to communicate literally at the speed of light.
That is insane.
It is. But the deeper significance of laying out this roadmap all the way to 2028 is really about market capture.
Right. From a business strategy perspective, when you show your customers 3 generations of breakthrough tech into the future, you aren't just selling them chips today, you are raising the switching costs.
Precisely.
Like if you are a hyperscaler, a massive cloud provider, and you can see exactly how NVIDIA's hardware, networking, and software stack will evolve and integrate over the next 4 years, why would you risk billions of dollars trying to piece together a fragmented alternative from 3 different competitors? It borders on corporate malpractice to get against that roadmap.
You'd be crazy to try. The integration across those 5 layers of the AI layer cake is just too tight to easily replicate. I mean, think about it. They are simultaneously providing the power management software, the physical silicon, the edge networking, the foundation motors for robotics, and the agentic operating systems for your PC.
It's an absolute monopoly on the future. Okay, so let's bring this all together for you, the listener. We have covered an immense amount of ground today. We've gone from the death of the traditional data center to the birth of the gigawatt token factory.
Yep.
We explored how the inference era requires massive reasoning loops, which is leading to agentic software like NemoClaw poised to replace traditional point-and-click apps entirely. We've got robots downloading Kung Fu and the Matrix through synthetic simulation. We've got cell towers thinking for cars, and literal data centers processing intelligence in orbit.
It's a lot to take in. But the primary takeaway for you listening, whether you are an investor trying to allocate capital, a developer writing code, or just a professional trying to stay relevant in your career, is that the era of AI that thinks is officially over. We have entered the era of AI that does.
AI that does that.
The physical and digital infrastructure is now fully in place for autonomous action. Going forward, your personal or corporate OpenClaw strategy, meaning how you deploy and manage AI agents to do actual work on your behalf, is the single most important metric that will define your success over the next decade.
It really is a whole new world. And that leaves us with one final lingering question for you to chew on as you go about your day. We talked about NVIDIA turning the robotics data problem into a compute problem by training models entirely in synthetic AI-generated simulations, right?
Yeah, removing the real world entirely.
Well, if the AI no longer needs us to drive cars or move objects or write code in order to generate training data, what happens to the value of human-generated data in a world where AI learns everything it needs to know entirely from itself? Think about it. We'll see you next time.